Hello students, welcome back. Let's go to section 5, library of functions. This too is an optional topic. Excuse me, better take black font. Okay, we are ready. Here's some examples of power functions. Y equals to x to the nth power. The graphs look like this. Look like these, in plural rather. So y equals to x, y equals to x to the third power, fifth power, odd power. We have these kind of graphs that are symmetric about the origin. Now, even power, y equals to x squared, fourth power, sixth power. In that case, symmetric with respect to the y-axis, and the function value is always positive. Remember, positive square is positive, negative square is also positive. So these can go as low as 0 and y coordinate 0, and that's about it. Doesn't go any lower than that. So the range for these kind of things will be from 0 to positive infinity. Range for these kind of things from negative infinity to positive infinity, or y coordinate values. Radical functions, do we really need those? Well, we sometimes do have square root functions, so let's talk about those. Square root functions, and then fourth root functions, part of parabola, a part of this, it's not exactly parabola, it's a little bit stiffer here and then flat over there, and so on and so forth. All these are even radicals, so valid only for positive numbers inside. Now, cubing root, fifth root, those kind of things, they have these kind of graphs. But even for these kind of graphs, me personally, I'd like to restrict ourselves only to the positive numbers inside all radicals. That'll make problems simpler. And come on, this is 1000 level course, so let's keep things simple. Whenever you have radical, just consider positive or at least non-negative inside as well. 0 is okay. Oh, excuse me, even 0 is problematic, excuse me. If you have negative power, then 0 goes to the denominator, so that's a problem. So, okay, all right, I take it back. Let's keep the inside of any radical positive 99% of the time. Fraction functions, okay, negative power, so x to the something power in denominator, x to the something power in denominator. We have vertical asymptote when denominator hits 0, because dividing by something really small will blow things up to positive or negative infinity. We have these kind of graphs, but that's where I'm going to stop. It's getting a bit too deep. For STEM algebra, for Maths 13-14, this is going to be important, but for us, not much. Let's see, in general power function, no, getting too deep, so let's not worry about these. Anything else that we have to consider? Absolute value, okay, always positive. Floor function, business algebra frequently deals with floor function and ceiling function, to tell the truth. In business mathematics, frequently we have to take, let's see, do some rounding, either rounding down, forcefully down, or rounding up, forcefully up, by necessity, and then consider what's taken off as just consider those as loss, and then go on from there. And that's very, very common in business. So these kind of functions do appear. So in the simplest case, floor of a certain decimal, we simply take the integer part, for example, like this, 6.715 is just 6. taking the integer part. And ceiling function is similar. Let's simply take the same thing, 6.725, but it's forcing to round up. I don't know whether we'll deal with these a lot in this course, but remember, these forced rounding, and then considering the loss and then moving on, those kind of things are very common in all kind of business mathematics. So we may have to consider these floor and ceiling functions in this course too. We'll see. Piecewise defined function. Okay, all right. These kind of things. For a certain interval, we have one definition. Another interval, we have another definition. And then another interval, we have another definition. And here in this example, we have only 3 intervals, but there can be many more. You see, when x is less than or equal to -2, this function, which I highlight in blue, and then between -2 and +1, we have this red function, and then when x is greater than 1, this green function, and in this particular case, red and green merged together, no discontinuity, but blue and red, we had a jump. And then these kind of modelings happen a lot. For example, if you track down some performance of a company or something, performs one way, and then after something drastic happens, something like the company's new drug was approved by FDA or something like that, and then suddenly business takes off, so another model takes place, and so on and so forth. So for each time frame, we may have different modeling. So putting together with piecewise defined functions are commonplace in business application. So we'll try to deal with these kind of problems as well as early as next week, but of course in a much simpler fashion. Those kind of things are library of functions. Are we going to deal with more types of functions? Well, let's see. We will deal with exponential and logarithmic functions later, but we are not ready yet. So those are not in our library yet. And we will not deal with trigonometric functions. So for now, our library is kind of limited to these functions we just talked about. Okay, let's stop here. And we'll discuss section 6 in a separate video.